Okay, one more for you just so you can see one of the things that happens. In every problem we've done so far, the k value has been 1, so it's been easy to see how many terms there are because you can just do 8 minus 1, or from 1, well, you don't even subtract them. From 1 to 8 is 8 terms because you have 1, 2, 3, 4, 5, 6, 7, 8. That's 1, 2, 3, 4, 5, 6, 7, 8. Easy to figure out. The difference that comes in on some of these, your k value or your starting value is not 1. So if you look down here at this one, k starts at -3 and we go to 8. So when we're computing our value for n, there's more than 8 terms. We're not just going to use that n value at the top. We have to pay attention to how many terms are built in. So if you think through this, we start at -3, then -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. This ends up being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 terms. So it's kind of like if you subtract those numbers and then add 1, will give you your total number of terms because you have to keep in mind that 0 term. So it even works up here, like 8 minus 1 is 7 plus 1 is 8. 10 minus 1 is 9 plus 1 is 10. 8 minus -3 is 11 plus 1 is 12. So on these problems where your n value down here, excuse me, not your n value, 12, where your index is different than 1, you're going to have to compute how many terms there are, but you can just do top minus bottom plus 1 and that'll give you your n value. Okay, so to do this one, we start off with a sub 1. We are not plugging in 1. This means this a sub 1 means the first term. The first term has a k value of -3, so we'll say 5/8 times -3. Okay, because again, that 1 doesn't mean the number 1, that means the first term. So then we end up with -15 over 8. A sub n, okay, this is my last term, okay, so this is not n, like the number of terms, this is the last term. This is why he uses that weird formula, because it kind of builds it in, but we just want to find the value of the last term. A sub n is the value of the last term, which happens to be the number 8. So then we're going to plug in 8. We'll say 5/8, oops, it disappeared. Why are you doing this? 5/8, there we go, times 8. The 8's cancel each other out, and we get a value of 5. Okay, so in my formula, n all by itself is going to be the total number of terms in that series. When we're computing the value of a sub n, we plug in that top number. That is the value of the last term. When we plug in 8, that gives us the value of the last term, which is in this series the 12th term. Hopefully that kind of clarifies the difference between those there. So in our formula, we're going to say n, the number of terms. We have 12 terms. The value of the first term is -15/8. The value of the second term is 5. We're going to divide that by 2. In order to get our fractions nice and happy here, I'll zoom us in a little bit, we can change 5 into 8s. 5 is equal to 48. If we make a common denominator, now we're going to simplify some things down. We've got 12 times -15 plus 40 would be 25/8 over 2. 12 times 2 reduces to 6. So we've got 6 times 25/8. 6 and 8 both reduce. They both divide by 2, so this is 4. This is 3. That makes it easier to multiply these, so we end up with 3 times 25, 75 over 4 would be your final answer. Okay, so when you see your index, your starting value is not a 1, you're going to need to figure out how many terms are in your series in order to find this n value that goes into your formula. Okay, as long as you pay attention to that, you'll be great. You still use the top number when computing the value of your nth term, but you need to figure out the total number of terms to put it into your formula. And that's how you can kind of bypass using that weird a sub 1 plus n minus 1 times d formula throughout every single problem. So hopefully